So far, we have looked at hidden Markov model, part of speech tagging with hidden Markov model, the task of sequence labeling, where the words of a sentence are given different kinds of labels. Now, today we would like to start a very interesting topic, namely the relationship between two extremely important and large fields which deal with textual information, namely information retrieval and natural language processing. So, if you see the title of today's lecture number 22, that is natural language processing and information retrieval. It so happens that both the fields are predominantly concerned with text. Of course, music retrieval, video retrieval, image retrieval and so on are very important fields in information retrieval, but the fact remains that predominantly people look for textual information on the web, and in the science and technology and art of information retrieval is concerned with how to retrieve and present textual information. Natural language processing also is concerned with text. It makes use of linguistics, makes use of structure of sentences and the meaning of sentences to see how language is produced and how language is understood by human beings. So, both the fields are concerned with text and expression of language in the form of textual data. So, it is very natural that the fields, both the fields would have a lot of things to do with each other. There should be a kind of synergy between natural language processing and information retrieval. However, if one looks at the history of information retrieval, it started with the task of retrieving information in specific information bases. For example, in library information system, how would one obtain a book given some specifications for the book, like the author, topic, subject and so on, sometimes in the form of a very dry and precise information like the catalog number of the book. However, the information now is largely resident on the World Wide Web. There is a tremendous amount of information and large volume of information, large diversity of information on the web, and one would like to retrieve this information from the web. Therefore, information retrieval in the context of the web has become far more important than just specific information search or corpus search. So, information retrieval is dealing with obtaining information from the web predominantly, but also could be from specific information bases. Natural language processing, on the other hand, is concerned with the language data. If one looks at the history of the interaction between both the fields, there is this intuitive feel that natural language processing is definitely useful to information retrieval, which is concerned with obtaining textual information. And natural language processing also can benefit from information retrieval, because for certain language phenomena, lots of textual information can be presented to the natural language processing system. So, both the fields should be helpful to each other, to say the least. However, one sees that information retrieval and NLP, in spite of their intuitive relationship, have maintained a respectful distance from each other. Information retrieval researchers have gone ahead with engineering of large systems without really bothering about the nitty-gritties and fineness of language processing. Language processing, on the other hand, has made use of the web to obtain evidences for language phenomena, but that is all. Many different techniques of information retrieval have been looked at with interest, but it is doubtful that NLP has made use of lots of IR techniques. So, today we would like to discuss these issues in more detail, and we will take a perspective view to see where IR NLP are placed with respect to each other. So, if we take the AI perspective, which is pre-web, then there is this diagram of AI, which is a classic. Actually, there are these core areas of artificial intelligence like search, reasoning, learning, some amount of planning, which are used by these areas of AI, namely robotics, natural language processing, planning, computer vision, expert system. The areas on the outer circle are those that make AI useful for human life. Computer vision, for example, is useful along with robotics for mechanical performance of tasks involving navigation, picking up of objects, and so on and so forth. Language processing is useful for creating natural language interfaces to computational systems. So, all these essentially make use of these areas of AI in the inner circle, namely search, reasoning, learning and planning. So, this was pre-web, but post-web one definitely sees a strong presence of information retrieval, which the AI community recognizes as important to AI. So, IR also makes use of important concepts in AI, which are core, though not necessarily the techniques of AI. So, there are specialized IR systems which try to do reasoning while processing the query and retrieving the document. Machine learning has contributed a lot to information retrieval, especially on the question of learning to rank. So, now post web AI, when this classical diagram is presented, cannot ignore information retrieval. So, now where does language and artificial intelligence come into play when we discuss information retrieval? So, this is a diagram which is concerned with the satisfaction of user information need. So, when a user presents a query to the web and retrieves information in terms of documents, then the user is actually presenting his or her information need to the search engine. Now, user satisfaction is completely a function of ranking of the documents which are retrieved corresponding to a query. So, ranking essentially means the placement of highly relevant documents towards the top of the list of documents retrieved. So, when a query is presented, for example, trekking in Darjeeling or tourism in Taj Mahal, when such queries are presented, a list of URLs are retrieved and the user would like to see that the relevant documents are towards the top of the list. So, this particular concern comes within the purview of what is called ranking. The documents are ranked according to the relevance. Ranking, on the other hand, is a function of two important things. One is coverage. After all, what is ranked is a list of URLs or web addresses containing information. For something to be ranked, for a list of information items to be ranked, the information after all has to be present. from wherever it is retrieved. So, this is the coverage issue, and it is concerned with coverage of information. Okay. The more the coverage of information, better is the possibility of obtaining relevant information. Therefore, ranking is a function of coverage. The other thing that ranking is a function of is the correctness of query processing. When a query is presented, the query is not matched directly against the documents. That would lead to what is known as the data sparsity problem. The query as such, in the same form, the form in which the user has presented his information need not be present in the document itself. The parts of the query would be present in the document, and then the document would be retrieved. So, query processing is concerned with breaking the query into important parts, remove suffixes so that the root word or the essential word is obtained. Okay. For example, plural markings like es, s are removed, the singular root form is obtained. So, those are the functions of query processing. It may be necessary to detect that there is a proper noun in the query, Shah Jahan, Taj Mahal, etc. And this is the task of query processing. And the better the accuracy of query processing, the better is the ranking of documents. So, this is shown here. Query processing is a function of stemming, that means bringing the words into their root or cardinal form. NER means named entity recognition, MWE means multi-word expressions. Multi-word expressions are like golf club, okay. Then frozen expressions like cut your coat according to your cloth, and so on. Coverage is a function of crawling, that means retrieving or storing the documents from the web in the private machine repository. So, this is known as crawling. How well one retrieves the pages, one picks up the pages from the web, and how frequently one does this is very important for the coverage. And once these documents have been obtained from the web, they have to be indexed. There is a very important process called indexing. This establishes mapping of important words to the documents which contain them. So, indexing also requires stemming to bring the words into their root form or a cardinal form. So, this is a very important picture where users information need is shown to be a function of many different processes. What is the role of language processing, artificial intelligence, etc., in the satisfaction of user information need? Where in the diagram does one fit the AI and NLP concerns? So, one thing is that when documents are retrieved and their words are stemmed, they often require language processing, accurate language processing at the level of words. For example, a Marathi word like ghara samor cha, near the house or in front of the house. Here the most important entity in ghara samor cha is ghar. So, it is important to strip off samor and cha from ghara samor cha and get ghar, which is then indexed. And the meaning of indexing, we already said, is that the word now will point to all those documents which contain ghar. Similarly, detection of named entities, detection of multi-words are natural language processing concerns. Of course, they can be done without linguistics, purely through machine learning statistics, but beyond a level one sees that language issues or language properties have to be used for higher accuracy in these processes. The use of artificial intelligence is in the fact that there is a human user who is presenting the information need, and the human user has a mind of his own. The human user is a cognitive entity, and cognitive science, cognitive psychology, modeling of the user, these things are very much concerns of artificial intelligence. So, this diagram therefore establishes a sort of platform for where AI language processing could be useful to information retrieval. Proceeding further, we take some examples. Suppose there is a query Indian tribes in Latin America. So, this is a piece of query, presumably the query maker's information need is to find out things about Indian tribes in Latin America. So, Latin America is the countries consisting of Brazil, Argentina, Cuba, Mexico and so on, and one would like to know the existence, means of livelihood, properties etc. of Indian tribes in Latin America. So, when this query is presented to Google search engine, for example, one sees that this is the URL which is retrieved, Indians of Latin America and exhibition of materials in the Lili etc. etc. So, Lili library is in Brazil, which is a large map of colors. This locates the course of rivers, towns, mountain ranges, Indian tribes etc. And this is not exactly what the user has asked for. This is about a particular library, whereas the user wants to know about the Indians of Latin America. Indigenous people of Americas, this is from the Wikipedia, it is a Wikipedia document, and here is a small snippet of information which gives a glimpse of what is there to come inside the URL itself. So, American Indian creation legends tell of a variety of originations of that it had confirmed the presence of 67 different uncontacted tribes in Brazil. So, this seems to be relevant to the query. The first document which was retrieved was not really relevant. Cognition, this is another URL. The volume that Farabi produced from his travels include Indian tribes of eastern Peru, motor vehicles that are lemons etc. etc. This also does not really seem relevant. It of course mentions a book that somebody called Farabi wrote, and there the Indian tribes of eastern Peru, a very specific region of Latin America is mentioned, but the URL is not about the habits, livelihood, origination etc. of tribes in Latin America. Next URL is top 25 American Indian tribes for the United States. Top 25 American Indian tribes for the United States 1900 and 1980 etc. etc. So, this is also a book. 10 largest American Indian tribes infoplease.com. So, this is another URL, and this also really does not satisfy the information need of the user. The Indian tribes of North America by John R. Swanton of Questia. This is also a notification of the existence of a book or an advertisement. So, as far as relevance is concerned, one would think that the second URL was relevant, the first URL was less relevant. What is the story for Yahoo when this query is given to Yahoo, Indian tribes of Latin America? So, it brings up this document, South America Daily, Indian paper photos, prices by spices, the Times of India, archaeologists unearth ancient tribe members, Sakri London, It talks about some ancient tribe members, but not really of Latin America. Native American Indian cultures, also many of the Yanomamo tribe are losing their members and culture by etc. of Amazon Indian tribal art in the world, with over 75 tribes represented. So, this is talking about a particular tribe existing in Mexico. It is relevant, but still is narrow in its scope of information. Native American Indian cultures, North American tribes, etc. So, this brings in information on Native American Indian tribes and their culture, not really that of Latin America, or not wholly that of Latin America. Indigenous people of Americas. So, this is about the indigenous people in North America. Native American images, this is about tribal map, resources for Indian tribe found in Brazil's Amazon, etc. So, here we see some relevant documents towards the end of the list. Alta Vista is an old search engine, and here we again see this document finding a place pretty much towards the top. Native American Indian cultures has come up, which was low in the list of documents that Yahoo presented. Indian tribes in Suriname, cross borders, etc. And again the information is specific to a particular region. MSN is another search engine. So, this talks about the first document it brings up, talks about Native American images, Indian North American tribe, and so on. Resources for is the next URL. So, Indian tribes in Latin America brings information about these countries, which are which is not really fully relevant, but at the same time can be used for useful purposes. Latin America Community Assistance Foundation. So, this describes some Indian tribes in Latin America. Latin America tour set for Curtis photos of North America tribes. Here the North American tribes are discussed, but not really those of Latin America, and so on and so forth. So, this example shows that if we take a query and give it to a search engine, then it is not necessarily true that the search engine retrieves important documents, the relevant documents from the web to be given to the user, so that the user's information need will be satisfied. That is not true. Different search engines have different levels of performance. Okay. So, we move now on to something called personalized focused search, where the accuracy of retrieval is much more, and one hopes to see very relevant documents populating the list of URLs which are retrieved from the web. So, Indian Latin American tribe is given as the query. Again, we see that the documents which are retrieved, like William Curtis Farabi, where this is an information about William Farabi's book on tribals in Indian tribes in Latin America. Mexican Texas settlers were empowered to create their own militias to help control hostile Indian tribes. Texas faced raids from both the Apache and Comanche tribes. So, this is about Texas facing problem from certain tribes like Apache and Comanche. This particular URL, Temecula, California, the Luiseno and Cahuilla tribes were believed rather bloodily in the local battles of the Mexican-American War during the following years. So, this also really is not presenting information on tribes in Latin America, and so on. Now, one could make queries which are semantically precise and one could then search for relations and events. So, for example, there is a query here, Afghans destroying opium poppies. So, this is about Afghans, the people of Afghanistan, and their act of destroying the opium poppies. Opium is a very important export from Afghanistan, and the national economy depends on opium. So, Afghans destroying opium is an important or a surprising piece of information. So, let us see what is retrieved in response to this query. So, Japan Today news, Afghans threaten to grow more opium poppies. So, you see the query was Afghans destroying opium poppies, and what is retrieved is a document which exactly talks about the opposite information. Here Afghans threaten to grow more opium poppies, they are not destroying opium poppies. This particular URL, Afghans on losing sight of the drug war, makes a lot more sense to grow poppies and opium instead of. So, here again the URL essentially discusses growing more poppies rather than destroying it. News hour.extra, Afghans vote on first democratic election. So, Afghans now farm poppy for economic role in the manufacture and sale of poppy. Here also the URL is about Afghans voting for democratic election, where incidentally the issue of growing or destroying poppy comes up. There is a PDF file from where again the snippet is picked out and presented. The weapon is the opium poppy used to produce heroin. American embassy who fear that the Afghans are in one, it is no good destroying opium unless etc. etc. So, again we can see an URL which is not talking directly about the act of destruction of opium poppies. So, semantically precise search for relations and events would have solved this problem, because Afghans are actually destroying opium poppies, whereas all the URLs, almost all the URLs talk about growing more poppies. Now, these a few examples illustrate the need for robust textual information inference task. So, if we look at this task, does text T justify an inference to hypothesis H? On the assumption that some piece of text T is true, does this imply the truth of some other hypothesis text H? Sydney was the host city of 2000 Olympics. The Olympics have been held in Sydney. So, here is an example of this. Sydney was the host city of the 2000 Olympics. The Olympics have been held in Sydney, which is a true entailment. So, the question is it that the hypothesis text follows from the text which is given before? So, in practice an informal intuitive notion of inferencing is used, which is strictly not based on logic. It incorporates pragmatics and default assumption. The focus is on local inferencing steps, not long chains of deduction. Includes basic word knowledge, but not highly technical material. Relevance logic is used. Text must inform hypothesis. So, the discussion on this particular slide is that there is a need for inferring a piece of text from another, and the task of information retrieval can be looked upon as drawing an inference from the query as far as the documents retrieved are concerned. So, we can look upon the retrieved document as being entailed by the query. So, it becomes an inference problem, can the document be retrieved from the query? All right, we proceed further. We do a bit of digression and we describe very quickly the large project on cross-lingual information access. This is an India-wide endeavor on cross-lingual information access. Now, the motivation of course of such activities is well known. Not everybody would be able to use English to satisfy his or her information need. English is still the most dominant language on the web. contributes to 72% of the content on the web. So, as is shown here, millions of users. English has about 380 millions of users, followed by Chinese. They number 185, Spanish number 183, Japanese 88, French 64, German 67, Portuguese 51, Arabic 46, Korean 34 and Italian 33. So, these are some top players in terms of language on the web, and we can see that Indian languages still do not figure anywhere for this internet usage. So, it is therefore quite conceivable that it should be possible for non-English speakers, non-English users also to be able to cull out information from the web by making non-English queries. The number of non-English users is steadily rising all over the world. English penetration in India is estimated to be around 3 to 4%, maybe at most 5%, and that too mostly in the urban educated classes. So, there is a need to enable access to information on the web through local languages. So, with that important aim in mind, Government of India started cross-lingual information retrieval project, and many institutes are involved in this, with IIT Bombay leading the effort. So, here is a schematic of what goes on, and the user can very easily appreciate the tasks involved. For example, there is a need in the mind of this user about knowing about Tirupati Yatra. Okay, this is a query in Hindi, which means visit to Tirupati, which is a holy shrine in India, with Lord Venkateshwara being the resident deity, and millions of people visit that shrine. So, presumably the person wants to know the details of Tirupati Yatra as to how he or she could perform this journey, where they could stay, accommodation facilities, food facilities, the ways to reach that place and so on. So, all these are in the mind of the user, but he does not frame a long and a precise query. On the other hand, he just writes on the search box Tirupati Yatra. This is a Hindi query, which now goes to the CLIR engine. The CLIR engine actually converts it into English or retains it as such. So, when the query is processed by the CLIR engine, the relevant documents are retrieved as shown here. Target information is in English, and there is a ranked list of results which the query has brought. So, the way the information flows is that the query comes in to the CLIR engine and is translated, subjected to all kinds of ambiguity and other language constructs. The web has been crawled, which I showed some time back. Crawl means its contents are brought over into the personal computer. So, web is crawled and the indexed web pages are also there. So, relevant web pages have been indexed with the keyword. So, target language index is in Hindi. So, given the Tirupati Yatra, okay, it first finds out whether the information is contained in any document in Hindi or not. So, that leads to what is called the monolingual retrieval, monolingual IR. The query is in Hindi and the document that is retrieved is also in Hindi. But what is more frequently done is that the language query is given, and using language resources, using many such modules, the query is converted into English, and then the English page is matched again the content of the web in English. So, target language index in English. So, the query was in Hindi, we have retrieved documents in English. This shows cross-lingual information retrieval. However, the information has to be presented observable by the user. Therefore, the English pages may have to be translated into Hindi, or the essential information from this should be available in Hindi for the user to appreciate the answer. So, this for example, query for example retrieves a document containing these sentences. तिरुपति आने के लिए रेल साधन, तिरुपति पुण्य नगर पहुँचने के लिए बहुत रेल उपलब्ध है. अगर मुंबई से यात्रा कर रहे हैं तो मुंबई चेन्नई एक्सप्रेस गाड़ी से प्रवास कर लीजिए. Okay. So, this is a piece of information which the web has thrown at the user. All right. The result is obtained in Hindi, and this is the snippet. So, the challenges which are involved in cross-lingual information access are the following: indexing, retrieval and ranking of multilingual documents. All these documents should have been crawled a priori from the web, and they should have been indexed to be available to the search engine, and ranking of multilingual documents should be there, so that the user can find the relevant documents towards the top of the list. So, web data is not clean and regular, different font encoding, some of them proprietary. Most of the Indian language content is available in multiple fonts, which is a non-standard way of writing the text, depositing the text. And the problem there is that if the queries encoding is in one form and the documents encoding is in another, the matching will not succeed and the document cannot be retrieved. So, this is a very important problem. Most Indian languages have their own different sets of fonts. So, all fonts have to be standardized, which is typically UTF-8 font, Unicode. Spelling variations are very common. For example, one could write Nandan with half na, or Nandan with a bindi on the. So, I just write it to show you. One could write Nandan this way, which means pleasure or sun, etc. Or one could write half na, so this is Nandan, again meaning the same thing. It is not uncommon to see ladka, which means a boy, to be written without this dot. Okay. Many times it so happens that this dot is not given. However, people can make out that this is ladka, meaning boy. So, spelling variations are quite common in Hindi and in a number of languages. The documents themselves are encoded in many different ways. So, all these challenges have to be met before cross-lingual search can happen. Many times it is important to do language identification to invoke appropriate language analyzers. So, if the cross-lingual information retrieval engine is such that it also does the job of identifying the language in which the information should be presented corresponding to the query, then that would require language analyzer. So, is a particular document in Hindi or Marathi? So, we also know, for example, that I will write it down. Devanagari as a script is used by Hindi, Marathi, Nepali, Konkani and Sanskrit. So, the problem with this is that how to detect that a document in Devanagari is in a particular language. This is the question: how to detect that a document in Devanagari is in a particular language. This is a language identification problem. So, the language analysis involves a number of fundamental NLP research problems like query disambiguation, machine transliteration, named entity recognition, multi-word recognition, and so on and so forth. So, we will see examples of all these when we deal with actual queries, but all these tasks are deep and difficult NLP tasks. Now, the cross-lingual information access project is being done in a consortium mode across the country. This is under development. The input could be a query in any of these 6 Indian languages, namely Hindi, Bengali, Telugu, Tamil, Marathi and Punjabi. The output is in Hindi or English or the input language of query. That means 3 kinds of outputs are possible, either in the language of the query or in Hindi or in English. The domains have been released, the domain in which this task is to be implemented, that domain is tourism. So, one might wonder what is the role of domain in this search engine. The point is that the queries are, let us say, in tourism domain, then it is important to get the documents from that particular domain. And if the resources and tools are built with the domain in mind, then the accuracy is also high. So, it involves 10 academic institutes all over the country, IITs, Indian Statistical Institute, CDAC, Anna University, Jadavpur University and so on. IIT Bombay is the overall coordinator, which is responsible for Hindi Marathi language verticals. It includes full-fledged search features like snippet translation, summary generation, information extraction, in addition to searching. The portal can be seen here in this URL. Public portal is also released. Now, the processing of the cross-lingual information access system can be understood from this block diagram. There is what is called the online processing and the offline processing. So, when a query is presented, first it goes through language analysis, namely stemming. That means, getting the root words or the unsuffixed words from the sentence. Then there is named entity recognition, identify all the proper nouns. So, below each task, the name of the institute is given. Anna University KBC is supposed to implement this named entity recognizer. Multi-word expressions have to be detected. These words always hang together and they have to be accurately processed, and documents containing them have to be retrieved. Query translation is the task of converting the query into the target language's form. Query transliteration also is to be done, which converts proper names into the target language form. Query disambiguation is required because the words in a query typically have multiple meanings. The meaning that is most relevant to the current context, if the context is available, then disambiguation has to be done. Indexing has to be done, by which one gets a list of words and maps them to the documents which contain them. So, this is a line of processing on the query and the document. Searching and ranking is done once the query is given of the documents. Then comes the task of processing the output and presenting it. When the document is retrieved, URL will be opened by the user, but before that one should give a short snippet of what is contained in the document. This is the snippet generation. Now, snippet has to be translated because the query was in a different language. Template based information extraction can be done. For example, if the document is about Jaipur, which is retrieved, then the user may quickly want to know what are the important places for sightseeing, hospitals, police station, etc., etc. The document may have to be summarized and translated and shown to the user. So, this particular path of language analysis, NER, MWE, query translation, query transliteration, query disambiguation, indexing, index accessing, searching, document summarization, snippet template, and then giving it to the user, these are online processing, and they are done with respect to the query that is presented to the user. This particular task has to be supported by a tremendous amount of work offline. So, from the web the documents are obtained, fonts are transcoded, then something called CMLification is done, that is intelligent tags, sophisticated tags are placed in the document, language identification is done for the document, domain identification is done. We mentioned tourism, named entity, multiwords are detected from there also, and this information is converted into index. There is another path called UNL based search, which is advanced search making use of semantic relations. We can talk about that later. So, we have discussed today the relationship between information retrieval and NLP, and also described the cross lingual search project going on in the country. We will continue from here.